On August 12, 1985, Japan Airlines Flight 123 departed Tokyo's Haneda Airport at 4:12 p.m. with 524 people aboard, 509 passengers and 15 crew members. 12 minutes into the flight, at 24,000 feet above the Izu Peninsula, something catastrophic happened. The aircraft's vertical stabilizer, the large fin at the tail that keeps a plane stable, suddenly separated from the fuselage. What followed was a 32-minute struggle by 4 skilled pilots to keep a mortally wounded Boeing 747 in the air, a fight they would ultimately lose. The root cause lay not in 1985, but in 1978, 7 years earlier. Japan Airlines contracted a routine maintenance repair of the vertical stabilizer at their maintenance center in Haneda. 2 hydraulic jacks needed replacement. During this repair, mechanics made a critical error. They incorrectly spliced 2 hydraulic lines together. Instead of using a proper repair method, they used an adhesive bond without the required metal splice plates. This single mistake created a structural weakness that no one would detect for 7 years. For 7 years, Flight 123 accumulated flight hours with a compromised tail. The faulty repair point, located at the lower section of the vertical stabilizer, bore the full pressurization loads of the aircraft with every flight. Metal fatigue is a relentless process. Microscopical cracks developed and spread through the weak bond line. Then, on that August afternoon in 1985, the accumulated stress exceeded the remaining structural integrity. The adhesive bond failed catastrophically, and the entire vertical stabilizer tore away from the airframe in seconds. With the vertical stabilizer gone, the 747 lost all pitch and yaw control. The aircraft pitched upward uncontrollably and rolled hard to the right. Captain Masami Takahama, flying the aircraft, felt the sudden violent motion and heard a loud bang. He had no way of knowing that his tail was no longer there. The flight engineer reported abnormal readings. No emergency light indicated a structural problem, because no one had designed a sensor to detect a missing tail. Within seconds, the crew realized they had a catastrophic hydraulic system failure, though they did not yet understand why. The 4-person crew, Captain Takahama, First Officer Yutaka Sasaki, Flight Engineer Hiroshi Fukuda, and Flight Attendant Keiko Kariyama in the jump seat, fought desperately to regain control. They discovered that all 4 hydraulic systems had failed. In modern aviation, hydraulic redundancy is the safety net. With 4 independent systems gone, the pilots had only one option: use the engines themselves. By adjusting the throttles of the 4 turbofan engines, they could control pitch and roll. For the next 32 minutes, they flew the dying aircraft using engine thrust alone, a technique no pilot had ever successfully executed on a 747. Radio transmissions between the flight crew and Japanese air traffic control tell the story of their struggle. At 6:24 p.m., Captain Takahama transmitted, "Japan Air 123 request immediate return to Haneda." Controllers cleared them back to Tokyo. But the 747, now unstable and descending, could not hold altitude. The crew declared a mayday. Takahama's calm voice, speaking in English, reported, "Uncontrollable aircraft." He was fighting the controls, making constant engine adjustments to keep the nose from pitching up. But the aircraft was descending toward the mountains south of Tokyo. Visibility was poor due to weather. The crew never spotted the terrain ahead. At 6:56 p.m., Flight 123 struck the ridge of Mount Osutaka near Ueno village, approximately 62 miles northwest of Tokyo. The aircraft hit the mountainside at high speed, broke into multiple sections, and burned. Of the 524 people aboard, 520 died. Only 4 survivors were pulled from the wreckage: 3 female flight attendants and 1 male passenger, all from the rear section of the aircraft furthest from the initial impact. It remains the deadliest aviation accident in history, a record that stands nearly 40 years later. No single air disaster has claimed more lives. The investigation that followed was thorough and devastating in its findings. Japanese aviation authorities and the NTSB traced every system failure back to a single point: the faulty repair in 1978. Metallurgical analysis of the recovered tail section showed the adhesive bond had been completely inadequate for the structural loads. Internal pressure and fatigue had caused microfractures that propagated slowly over 7 years and 12,318 flight hours. The repair had never been properly inspected or pressure tested. A single maintenance error, uncaught by quality control, had set in motion a chain of events that would claim 520 lives. This disaster transformed global aviation safety. Regulatory agencies worldwide implemented mandatory structural inspections for pressurized fuselages, particularly around repair points. Aircraft maintenance protocols were rewritten to require documented pressure testing and proper documentation of all repairs. The concept of fail-safe design was reinforced. Systems must be designed so that a single point of failure does not cause total system loss. Boeing and other manufacturers redesigned hydraulic routing to prevent multiple system failures from a single structural event. The lessons learned from Flight 123 are embedded in every modern aircraft design today. Japan Airlines Flight 123 remains a sobering reminder that aviation safety depends on meticulous attention to detail at every step, from initial repair through quality control to routine maintenance. Captain Takahama and his crew displayed extraordinary skill and courage during those 32 minutes, fighting impossible odds with no hope of survival. Their struggle bought time that could not save them, but their actions and the investigation that followed have saved countless lives in the decades since. The 520 people who perished that day are remembered not only as victims, but as the catalyst for the safety systems that protect every passenger flying today.